So today we will discuss about dimensional modeling. So the model that we use in data warehouse to design our joins and all those stuff. So this is called dimensional modeling. So generally, what is a data model? Data model is nothing but a model which gives you a brief idea what is a primary key, which is a foreign key, and how the tables are entities are joined in your database or data warehouse. Okay, so what you do, you take help of data model from your OLTP systems. You meant to say primary key, foreign key, and all. See, for data warehouse also you need a data model. You need to know which is a primary key, which is foreign key, and all those stuff. Here, instead of designing it into like more in like a normal table, what we do in data warehouse, we design them as dimension tables and fact tables. So we'll just see the basic concepts, how the modeling has been started, like what is a logical model, what is a physical model. Then we will see what is a dimension and fact. Then we will slowly see what are the different schemas present, different type of schemas that are present here. Okay. So today we will start with what is a logical model. Then we will just see what is a physical model. And then we will slowly proceed with dimensional modeling. And then we will follow it with different type of schemas that are present. Okay, that are useful for us. Okay, so now just let me start with your logical model. So when I say what is a data model is a conceptual representation of data structures. You can say it as tables. And data model helps a functional and technical team in designing a particular database. And you have different two types of data modelings. One is a logical model and one is a physical model. When I say logical model, it really does not have any existence on any database. It's like a blueprint. So how can I correlate? When I say logical model, it is like the plan to build a house. House really does not exist. House can be constructed in any place or any location. Okay, or any floor. Maybe even if you are in an apartment, you can build it anywhere. But what does a logical model tell? I should have 2 bedrooms. I should have a hall. I should have this one. So this just gives you this just acts like a blueprint for a real implementation. Okay, so that is how your logical modeling starts. Okay, before implementation of any database or creating any set of tables, you need to know what tables needs to be created and what are all the columns that you want. Okay, so all those can be designed in your logical model itself. Okay, so it will just have tables, attributes, and relationship keys. Okay, and use business names for entities. So it does not really define you which data type needs to be used, which should act as it will just tell you which should act as a primary key or foreign key, or whether it is the key column. But it really does not tell you which data type to be used, how much length it should be there, and all. So all those specific things you need to handle it in physical modeling only. Logical model will only tell you I need an entity called as customer. Okay, it will give you customer name, customer ID, and all this. It really does not tell you whether customer ID is an integer or customer name is a varchar. All those stuff will be handled in physical modeling only. So when I say physical modeling, see, physical modeling will be implemented on a particular database, maybe Oracle or Microsoft SQL Server or IBM DB2, anything. So now you have a physical existence there, where with respect to a particular database, you should have data types defined. You should have the table or entity. Sorry, you should have the table or entity created, and it should be available for query. So that is a physical model. So you can just go through this. Includes tables, columns, keys, data types, validation rules, triggers, procedures, everything. Okay. So whatever you design as part of your logical modeling. So when I say I am speaking something, so it does not have any existence, right? It is just logically spoken. but when I put it on the paper, it has a physical meaning, right? So it has some existence, it has a proof, right? So that way you can say you can correlate with your physical modeling. Now physical modeling uses more defined and less generic specific names for tables and columns, such as abbreviated column names limited by the data. So with standard names and standard naming conventions will be used. So that is what we are saying here. And there are, you can just observe the basic differences between your logical modeling and physical modeling. So you can see in logical model, for time, what I am doing, I am just noting it as time, date, date description, month. So I am just listing out all the columns that I want. But in physical model, what you can say, I am naming it with a proper naming convention, DAM underscore time. And for date, I am just giving it as date underscore ID, which is integer data type. And for date description, I am giving date underscore description, which is varchar 30. Like that you can see, and it is been joined to other tables. So all these you can just define it in your physical model. Okay. Now you have some basic differences. So represents business information, represents physical implementation of a particular model. It is just an entity, whereas when it comes to your database, we call it as a table. On paper, it is just called an entity. And you call attributes, and here you call it as a column. And you have primary key. Here you can even define primary key constraint. Here what you do on paper, you just write as employee ID is a hyphen primary key. You want it as a primary key. Okay. So there are some logical modeling. There is a tool called Erwin and Oracle Design. So those tools are used for your logical modelings. Okay. So you need not to worry about them also. Okay. Now here what you do, you define primary key constraint. So how do you define it? You can write constraint, right? So while creating table itself, you write like this: create table time. So you are writing something as date underscore ID, which is a date column, and you are writing as it's a primary key column, right? Constraint date ID underscore primary key, and you can write it as primary key, comma, and so on, different types of columns. So by default, your date ID primary key, sorry, not your date ID, you can say date ID is fine, or you can take as day, and no need to take as date, just take it as integer. So how do I store it? I can store it something like this, 2015 0101, like this. So this should be unique. So that is what I meant to say. I am writing it in my time table. Okay, so this is how you define your primary key. So this is what is being implemented in your physical model. You can write your own constraints on your columns as well. Okay, and you can say check constraints, or you define rules here. So I want salary greater than so and so value. So here you define check constraint for that. And when I say relationship, you have a foreign key here, and you have a definition here, and you write comments on particular columns or tables using your comment command. Okay, like this. Now,
what is the alternate key, Pratap?
Which one? User unique.
Alternate key.
Alternate key, you can say a unique key. You can define one more column. So you will not only have only primary column, right? You may define one more column as unique. So even that you can use it as a when you are querying, or when you want to use for some reference, you can use that column as well.
Right.
Like that. And now ER modeling, entity relationship data modeling, is used mostly in OLTP systems. So when I say ER modeling, you have entities. So what we call entities, like you can say tables. Okay, and here each and every item, every individual entity, it will be related to other entities with primary key foreign key relationship. So all those things will be taken care by your ER modeling. So generally ER modeling will be complex. So this is just a disadvantage, unfamiliar to business people. right? So when you have a lot of tables, even in Siebel you see S contact, contact X, contact XM, everything will be correlated. Okay, everything you have joint relationship. So your business people really don't care how they are joined. So there are a lot of it is mostly like unfamiliar to business people. So, but when it comes to data warehouse, it is pretty straightforward. What we do, we just show them like this, right? So we can just take one table and just we can write this as a person table instead of contact, contact, XML. We don't care all those, and we have something called a sales table, and just join them. So person and sales, which is more in terms of business, so which is very near to your business terminology, right? But your ER model really or your OLTP system really cannot accommodate this. It cannot accommodate this because pretty simple. It has a lot of objects, and each and every object is subdivided into again extension tables and many other tables. So obviously your ER modeling diagram will become more complex. Okay, and very slow query performance. Obviously, as we discussed, when we have lot of tables involved, always your query performance reduces. Okay, now when it comes to dimension,
Incomplete history is what?
yes, Gaurav.
In incomplete history, what does that exactly mean?
Okay, incomplete history. We don't store any history, right?
Oh, okay, okay, yeah, yeah,
Yeah, yeah.
right, right.
So it is just OLTP, incomplete history. So main why see we are heading to OBIEE. So when I speak about OLTP, I can have all these. I can only take advantages. So when I speak about warehouse, I want to take the disadvantages of our OLTP system for decision making. See, you cannot go and design warehousing tables to support your business, your day-to-day business, right? That has its own advantages. Your operations, your transactions, everything can be carried out only with that type of design. Whereas my decision making system should need this design only, right? Right? So
Right.
every design has its own advantage. So when I see when everyone can go in bike, why people go for car? Comfort, right? So when everyone can go with your data warehousing tables or your database tables itself, your OLTP table model itself, there is no need for anyone to go through all these topics like dimensions, facts, and all. They can still make use of your OLTP system table itself and make reporting, but that's not comfortable and that is not reliable. That is the reason we have a concept of history, we have concept of dimensional modeling, and all those comes into picture. Okay, like that. Fine. So dimensional modeling, when I say logical data model used to represent measures, dimensions that pertain to one or more business subject areas. So when I say subject areas, it may be sales or it may be finance or it may be marketing, anything, or maybe you can take a complete data warehouse. When I say dimensional model, it it gives you the relationship between a particular dimension and a particular fact. Okay, like this. And you generally prefer star schemas. You have snowflakes also. I'll explain you about star and snowflake. You have snowflakes also, but your OBIEE, we have a layer called business model and mapping layer. It only supports star schemas. It does not support snowflakes. So even if you have a snowflake in your data warehouse, that is converted into a star schema in your business modeling mapping layer. Okay, so your OBIEE purely supports only star schemas. Okay, snowflakes it will handle, it will take only in the physical layer. Okay, physical layer is just like a layer where you import all the metadata, give the join relationships. That's it. Okay, can easily translate into multi-dimensional database design if required. So it can even we can use each and every subject areas tables into different types of dimensions again. Okay, like this, and overcomes ER design shortcomings. So ER design has some shortcomings, right? What are those shortcomings? Complex, unfamiliar, and all this. So it can overcome all these shortcomings and give you a better advantage. So what are some advantages of your dimensional model is it is understandable, systematically represent history, so you store history, reliable join paths, high performance query, obviously less number of tables are involved. And when I say scalability, how can I explain you enterprise scalability? Hmm. So enterprise scalability means, can I tell you about it? Hmm. Scalability will what is this? I really don't understand why I included this. Okay, so don't worry, I'll tell you about this enterprise scalability. Okay, so you can just take about it is easy to understand and has more reliable join paths, and it gives you high performance queries. So these are the main advantages of your dimensional modeling. Okay, this I'll tell you. Don't worry. So enterprise scalability, I don't think so. It is so important at this point of time for us. Okay. Now, we'll just compare the differences between your ER diagram and dimensional modeling. So, all the shortcomings are being taken care in your dimensional modeling when it is compared with your ER modeling. Here, tables are units of storage. Here, cubes are units of storage. Even this is like you have to modify, not only cubes. Again, see, cubes will only be taken care if it is like M overlap. Again, in your R overlap, tables are units of storage. Okay. Data is normalized in OLTP or ER systems, whereas data is denormalized in your dimensional modeling. Several tables and chains are present, very few tables are present here. Detailed level of transaction data, here summary and aggregated data is present in your data warehouse. Normal reports, here you have more user-friendly interactive graphs, drill downs, everything you have in your uh, OLAP systems. In CBEL also you have CBEL reports when you see in OLTP systems. But those reports will take more time and those are not so user friendly. Just it will have normal tables and columns and just it will generate you a report. That's it. Whereas here in OBIEE we will have charts, we will have graphs, we will have drill downs and everything. Okay, like that. Now, we were speaking about dimensional modeling and all those stuff. So, here in dimensional modeling, the basic entities or the major entities are dimension table and a fact table. So, what is a dimension table? Which contains descriptive data or textual data, or you can say which contains descriptive data. That is more than enough for us. Okay, so what is a descriptive data? Which defines about some entity or which defines something about your one of the object. When I say employee, details related to employee will be stored in your dimension table. Okay, you can say represented as hierarchical as time, departments, locations, products. Dimension tables are sometimes called lookup or reference tables. So when I say lookup or reference tables, I think you will be using lookup transformation in your Informatica, right? If you are aware. So what does your lookup transformation do? You look for a particular value, you query for a particular value, and if it is matching, you will return a particular value. Suppose rowit and rowit are matched, you will be returning up, suppose say employee name. Employee ID are looked against each other and employee name. Similar way, your most of the times your descriptive tables are used to look to get some meaningful or textual data. That's it. It contains all you can say is it does not contain any metric. It does not contain any measure. So when I say employee dimension, it has all the details related to one particular employee. Okay, and when I say person, person and employee tables are different, right? So person is a real world end user. So all the details related to a real world end user will be stored in our person table. So on daily basis, these tables will get loaded. And there are different types of dimension tables. One is like slowly changing dimension, and you have something called as conformed dimensions. and you have something called as degenerated dimensions, and there are some other dimensions as well, so we can just have idea about these dimensions. This is more than useful for us. So what are slowly changing dimensions? When I say slowly changing dimensions, there are different types of slowly changing dimensions again. So did you guys anyone configure SCD type 1 or type 2?
Yes.
We do in Informatica mapping.
Yeah, correct. So yes, you do it in Informatica using update strategy transformation, right?
Yeah.
Yes.
Yeah. So what do you do with your SCD type 1? So now I think you can correlate what I am speaking about a dimension table. You load something called _D table in your warehouse, and there are different types of dimensions. When I say SCD type 1, SCD type 2, and SCD type 3, you guys should be more comfortable than me. Yeah. So just me give a brief idea. Now, if a person called ABC is moving from a location Bangalore to Hyderabad. Okay. So how does your SCD type 1 store? Will it store Bangalore information or will it override it?
Override.
Yeah.
Override.
Yes. So it will have only Hyderabad. Okay. And the same information, how do you store it in SCD type 2?
Two records will be stored. One with Hyderabad, the other one in Bangalore.
Yeah, one ABC Bangalore, and you have something called as current flag equal to N, right?
Yeah.
Yeah, and you will give one same integration ID will be there. ABC Hyderabad current flag equal to Y. So all your history is maintained in your SCD type 2 dimensions. So you achieve this using your update lookup transformation, and you look up for a particular value. If it is already there, you will look up for the value, whatever the value is changed. So if the value changed is yes, if the value is changed, we have to insert it or update it. So in the update strategy, there will be two update strategy transformations. So one will route you like this. So what will one do? One update strategy transformation and second one. So here you have the same target table, and what does it do? Here dd insert or update flags equal to Y, go through this transformation, and what does this do actually? This will go with a normal load. And here if it is only update means if it is update flag is Y. So when do you set update flag as Y in your previous transformation? If the value is been modified, and if the values are more, the previous record needs to be changed. So for that, what you do, you have your current flag, start date and end date, and all those values populated here, and you will just update the same thing in your transformation. You will make current flag equal to N, and you will update the same thing in your target table. So the previous records will get changed like this. Now same thing. And how does your SCD type 3 store? It will have a single record, but it will have different columns to handle this. So ABC, it will have something called as previous location and current location. Previous location will be your Bangalore, and you will have something as current location. You will store it as Hyderabad, and you can say effective date. So from when the latest changes have come up, like this. So if he is again moving from Hyderabad to Chennai or some other place, this Bangalore will be gone. So this Hyderabad will come to your previous location, and your current location will become Chennai. So this is how the different ways of handling your data in your dimensions. So when I say SCD type 2, you can generally take an example of an employee table, right? So what does, suppose say if a particular employee is getting married. Okay, so all the if a particular woman is getting married, So obviously all their details after marriage, their address will change and all those will change. So the previous information about the employee when she created some measure data and all those, I need all those to be retained. And I even want for the same employee, I even want a new data also. So I'll just make current flag equal to y for the new record, and all the new details will be popped up. So the old data is still being referred like that. So you can have your different types of slowly change. You have some more dimensions also, but even I really didn't implement SCD type 4 or type 6. Even you have SCD type 4. So you have any idea about SCD type 4?
No, I haven't implemented yet.
Yeah. So generally you don't go for this, and you have something called SCD type 6 also. So you generally don't go for these types of dimensions. Okay, so till
Right.
type 1, type 2 is a maximum used. That is what you can say. Okay, so this
Right.
is about, yeah, slowly changing dimensions. Then conformed dimensions. So what does a conformed dimension mean? Suppose say you take time dimension, so which has same meaning across all the facts. So I have fact 1 and I have joins with D1, D2 and D4. So I have fact 2, I have D1, D3 and D5. So you can say D1 is confirmed dimension across two facts. So it is being joined to two facts. It has same meaning. Same meaning in the sense it will give you time related information, and it is joined with same keys and all. So it can be joined across multiple tables. So it can, between two fact tables, you can say a particular confirmed dimension exists like this. And what does degenerated dimension do? Instead of creating an additional dimension table again, suppose say you want to refer only order numbers or invoice numbers or service request numbers, like any keys or all those stuff. So generally what you do, you need not to create any additional dimension table in the warehouse and maintain it. So degenerated dimension is a dimension which is derived from your fact table. So you have a fact table, and from that table itself in OBIEE, what you can do, you can just take few columns from that fact table and make one table act as a dimension table. You can do that. Okay, you can only pull relevant columns and make one table act as a dimension table. So degenerated dimension is a dimension which is derived from your fact table itself, which does not have a physical existence. Okay, it is derived from the existing physical fact table itself. Okay, like this. So you can
Like, can
just,
you give example of this, Pratap, degenerated dimension?
yeah, you can take, you have a lot of things. Suppose say you take something called W order fact. You have order fact, right? So in my business model mapping layer, I can just generate a degenerate. So you will have order dimension also. Suppose say if you don't have this, you can just go for W. You can just make a note of something called as order dimension or something like this, and you can take order ID or integration ID from your order fact into this, and you can take order status, all those things into this table, and just make this table act as a dimension table. So when it is joined to any other fact table, not with order fact, you can even join this with other fact tables, right, based on the widths. So that time you can just
So what
use all this stuff. There is no specific.
what my question is, like, this order fact would only be having this foreign keys of dimension tables and this thing measures, right? So when we
Yeah, see,
create a
that is
dimension,
what I am saying. When you go for degenerated dimension, it mostly you go for picking IDs only. It will not pick you mostly any descriptive information and all.
okay, most of the
See,
time it will be ID only, right? That is
IDs,
what I was asking.
yes,
Like,
yes,
no
yes.
descriptive columns would be there in
Yeah. Generally,
degenerated
order
dimension.
status you won't find it, but generally, if you are referring or if you are storing something in your order fact, you can still go ahead and pull that information also. Generally you won't do this, not an ideal case, only to pull suppose invoice number, you want invoice number in your report. So you need not to have a separate dimension for that, right? Invoice number will still come from a fact table itself, right? So you can just have that fact table, you can just take those columns from your fact table and create a particular, just it is like a different name, giving a different name and pulling all those relevant IDs into it and pulling it into a report. That's it.
what is the exact use of it? Can we use the very
See,
the same
90
fact table
only
to
see
those
it is
IDs?
generally used in 3 to 4% scenarios, not more than that. Because nowadays, if you go for BI apps, I'm sure that you will have dimensions for all the tables. Like if you are having a Siebel implementation now you are working with, right? So most of the times you generally, it's very rare scenarios you go for degenerated dimensions. Okay. But if you have everything built on like manually, then in that scenarios, instead of maintaining a separate table, generally you can pick all these values. So it's just, you can say, in physical layer you have fact table, but in business model and mapping layer you can have a different dimension table altogether. So it does not have any existence, it's just a logical representation. Okay.
Yeah, yeah.
Yeah. So you can see, yeah, the same thing what we discussed have here. So hold the dimensional attributes and all. So you can see what is what a dimensional table is and what are slowly changing dimensions. So the same thing have been written here. So you can just go through this. Okay. So type 1, type 2, and type 3 have been defined and degenerated. Yeah, so you can see a degenerated dimension is dimension which is derived from the fact table and does not have its own dimension table. Stored in fact table. Common examples include invoice numbers or order numbers. Use degenerated dimensions is often based on the desire to provide a direct reference back to transactional system without overhead of maintaining a separate dimension table. So again, instead of maintaining a separate dimension and getting any numbers or IDs from your OLTP systems or anything, so you need not to do that. Go to your fact table, pick the relevant IDs, so that that will be helpful to you. And conform dimension which has same meaning across multiple facts, and then you have your fact tables. So generally fact tables are often defined by their grain. So some are stored at day level, some are stored at month level, so all those stuff. Okay. Now we'll just see different types of fact tables, and your fact table will have measures and all the foreign keys related to a particular dimension table. Okay. Now, so fully additive facts, there are something called fully additive facts. So what are fully additive facts? If you are able to add all the measures in your fact table against all the dimensional attributes, then it is called fully additive. That means you can define the aggregation rule of a particular fact table or fact column, all the fact columns in your fact table as sum. So if you can do this, sum of like orders and sum of order, like sum of your order revenue. And see, generally you can even take count of orders, right? So that is not a sum. There you are not using your sum aggregate function. So if all your columns in your fact table can be summed up against all other dimensions, then it is called as fully. So it is just a name. Don't worry. If it is fully additive or semi-additive or non-additive, also we don't care actually, because fact table is a table which contains measures. That's it. That is what we want. We can use sum function, we can use average function, we can use count function or anything else on that. Generally, most of the times it will be semi-additive. Few will go with addition, and few will go with different other group aggregate functions that we have. Okay, it is just the functions that you can use on set of measures. So then we call it
Perhaps
full.
we have one example with, I mean, this which can be fully additive and semi-additive. I mean, can you explain with the help of an example? It would be more clearer.
Fully no, which can be.
I mean, just by example, like taking a table and its fact columns in it, and then showing it like it can be
Okay,
fully
okay,
additive and
okay. What we can take?
this is more clearer.
Sure, sure. So let me take a Excel sheet for this, so you will understand. So we'll store some data. So suppose say dimension table I have order 1, order 2, order 3, and order created date as today's date, something 22nd May 2015, and so on like this. And I have order number 101, 102, or 103, and order status as completed, in progress. or you can say open. Okay, like this, and I am taking a fact like row width. So I'll take some 111. This is a fact row width. So for order ID 1, suppose I have some revenue as 20, and I have commission as, suppose say, uh, commission amount that I got, suppose say 2 rupees or something like that, and then 111. So I have order 2, and what I can say, I can have some 30. So commission has some 4, something like this. Sorry, 112, and I have 113, and for order ID 3. So I can have some amount as 50 and commission as 5. So what I can do, so when I say, so only, just imagine fact table has only these 3 columns, these 4 columns, these are keys. So my measures, if I am able to add against my dimension tables, okay, so for measure, for order 1 I have 20, okay, then what you can say, okay, if I say total revenue, okay, revenue that I got, okay, so total order amount you can take. So this is the amount that you can take. Here you cannot even take count of your revenue, right? So here you want to perform only sum function. And here even on this column like commission also you can perform only sum, right? You need not to perform count on this. So if you want count and all, you can go with just count of your row widths. This will give you number of orders. Or here you count of this one also will give you a number of orders, right? So this fact, the fact table which contains measures, has the measures which can be additive against your dimensions. So for orders, you have all your order amount which is summed up. So which is summed up, and here you are not using any other function other than sum, right? So which is like sum of 11. You are not using any other functions. So what you can say, if you are doing like this in your business model and mapping layer, there is one functionality, okay, what there also again I will bring up this point. There is some tab called as aggregation, okay. For each and every measure column, by it is mandatory that you have to define aggregation. If you are not defining it also, it is proper, but if you are pulling something into a fact table and feeling that a particular column is measure, then you have to define your aggregation content. So aggregation will be, you will have all your group functions, sum, average, count, and all those. So if you are using only sum functions in your fact table, then it is called fully additive. That means you can say fully additive. It is just for terminology. It really does not have anything to do with your data or columns which are present. Okay, so if all your measure columns in your fact table has aggregation content defined as sum, you can say fully additive. If sum and some other functions are also used, you can say semi-additive. And if you are not at all using any sum function, if you are only using other functions, then you can say non-additive facts. Okay, so it is just for meaning, but as of now, don't worry about fully semi and non-additive facts. Keep in mind, a fact table is a table which contains foreign keys and measures. So that is what is being expected. That is more than enough as of now. Okay. Now you can just say semi-additive and non-additive. Example: age and weather. Okay, and here you have some examples: semi-additive and fully additive. Revenue. Generally, revenue will be fully additive fact table always. Okay, and the quantity and sales amount. Okay, so all this can be summed up across all the dimensions, right? So these are called fully additive generally.
What examples are semi-additive? Which one are semi-additive?
Semi-additive, what can you take? Do you have any forecast tables in your project? Do you have any forecast, like
No,
forecast monthly or forecast weekly? Generally we
no.
have forecast tables. Okay, what does we generally do there is not only some functions. So what we have count and average use. Mostly we use the average function. So what does your average do? So you take a measure, right? You go for average function there, because I want to forecast, I told you, right? I want to forecast it for, suppose, say 2016. I go for average with the previous years, 2010, 11, 12, 13, 14, and 15, and so on. So generally for a particular measure called, we have a measure called direct working forecast. So we have a table called WX weekly performance accuracy F. So this is a fact table which is a semi-additive, I can say. So here I have something called dir underscore working forecast. So this is like direct working forecast. I am not using any sum function here. We are using average. So if any particular column in your fact table, if you can use a different, what you can say, different aggregation rule other than sum, you can say these are semi-additive facts. Okay.
This means we can't do sum here, but we can calculate the average of it. So it
Yeah,
will be
you see, you can do sum also. It is not like you cannot do sum. See, on a column where you are performing sum, can't you do average? Can't you do
pardon me?
average?
Yeah, we can do average.
Yeah. So what I am telling is, see, it is just for naming convention. If you are able to sum up all the things, you call it as, hey, it's a fully additive fact. If you are not doing that, you call it is okay, it's semi-additive fact. If you are not doing it, it's non-additive. Why you really worry about whether it is fully additive or semi-additive? Why we are worried? Now, do we need to worry? All our job is
No,
to track the measures against a dimension. That's it. And I should be properly defining aggregation rule for my measure. Whether do I want to submit or do I want to, it's just an example. You can say it's just an example. Okay. You need not to really care. You really don't care whether it is fully additive, semi-additive or non-additive. We don't really care. Okay. That is still fine.
right.
Yeah. Now, you can say a schema. When you say schema, schema is a collection of database objects, tables, views, and all this. And there is a different way or different ways of arranging your objects in your schemas. Okay, general, the most popular ones are star schema and snowflake schema. When I say star schema, how these are joined? So you have a fact table which has all the foreign keys surrounded by corresponding dimension tables. So I have something called time dimension, and I have something called as sales fact table, and I have something called as employee. So which employee is doing this, and I can have something called as product, against which product, and all these are joined like this with primary key foreign key relationship. Okay, your dimension and your fact are joined like this. So which you can call this as a fact table, and these are called your dimensions. So this you call it a star schema. You don't have any extra join or additional join which is present from your dimension to dimensions. Okay. So this is the structure that is expected in OBIEE business model and mapping layer. Your physical layer it cannot avoid because it don't have a choice. Whatever is present in data warehouse, it has to accept that. Even if there is a dimension to dimension join, it has to accept it in physical layer. I'll show you. I will discuss about all those. But you can keep in mind your BMM layer always your OBIEE always supports star schemas. So this is how your star schema is present. Fact table is there and corresponding dimension tables are present across it. And when I say a snowflake,
Sudha, one question. Like,
yeah,
so we can't have a direct join between two dimensions in the star schema then?
then you don't call it star. I am not saying you can't have. Then don't call it star.
Okay. But in star schema, there can be multiple fact tables which can be joined to multiple dimension tables, right?
Yes, yes, yes. Now you can have like this also. You can have one more fact table here, and you can have join relationship defined here like this. This is also a star only, right? So this is your second fact table. Fact 2.
And can we have a scenario like we have a fact table, fact 3, and which are joined to dimension table 10 and 11, not related to other dimensions which are
No,
joined to the other
that's a different schema then. That's a different. You can not schema. You call data mart, right, or a subject area, right? You can say those will relate to a different, entirely a different concept. You can join with them or bring in new set of tables and join. See, it's not mandatory that all the fact tables should be correlated to one or the other dimension. It is, there is no rule, such rule. You can have different schema again here also. One fact, one dimension, and the other dimension. You can have a join. Only these three tables can be used. Pull the subject area into your presentation layer. Make reporting on these three tables only. Like that also you can do. Yes.
Yeah, my only question was like in the same star schema we can have these two scenarios, like, right? I mean where we have two fact tables and dimensions which are not joined to each other but have a different joined to dimension tables, right?
Yeah, all these are possible. Yes.
Okay.
Yes, you can have it. Okay. So
Yeah, yeah.
in the same way, what does a snowflake is? The same thing. Yeah, you need not to have dimensions here. Okay. So let me remove this part. Okay. So if you have an join with dimension to dimension, then you can call it as a snowflake schema. Okay, you can say this has a dimension 4. Okay. When does this generally come? Generally we have in BI apps. I don't think so. Most of the times it will be star schemas, but in general, what we can take is product and product subtype. Generally we store everything in a single table, but suppose say product subtype are present in two different tables. You can go product and product subtype joined with primary key foreign key relationship. But in physical layer there is concept of multiple logical table sources. We have a concept of multiple logical table sources in BMM. So using that concept, we can convert a particular snowflake schema into star schema. That I'll tell you while discussing with about OBIEE, right? I'll bring that point, how to convert a snowflake to star. I'll show you that. We need not worry. But keep in mind, a snowflake is a schema where you have dimension to dimension joins exist. Okay, like now you can just go through your star and how your star is. You have a fact table and you have dimensions, and how your snowflake is, and what are the disadvantages. So obviously you have more number of dimension to dimension joins, your query performance will reduce, it is complex and all. So like that. Okay, so it's snowflake schema. So how to design a star schema? You have initial design steps. So some you have to define at what table what is the fact, at what table your fact is present, what are the dimensions, and how those dimensions can be joined. And we have even concept of aggregate tables also, so we need not to worry. So we have something called aggregate tables, right? So what are aggregate tables? So can you just give me a brief idea? Can you tell me what are aggregate tables?
I don't know. I mean, the name suggests like it has the aggregate values of among multiple dimensions stored in a table.
Okay, let me tell you. Now suppose say I have, this is like, you can say W order fact, and you can say this is this, and this has date with suppose say like 2015 0101, and you have 2015 01 01. So all the records are created presented. Just keep this mind at present at day level. Okay, on each day 2015 Jan 1st 2015 02. So I'll have something called as W order aggregate fact. This may have different set of row ID. I don't have any order IDs which are being split. I will have something as 50. I have commission as 6, and I have this one as 201501, and I have something as 333. I have something as 50, or you can say if you have something as 60, suppose here you can take it as 60, and you have data for this as 5 201502. So what is the difference that you are seeing from this table and this table?
The below one is the aggregated one.
Yeah. So how you are saying this is aggregated?
It shows the sum of the values.
And see, what is the difference? See, obviously this should have a join to your dimension tables, whether it may be aggregate fact or normal fact, right?
Yeah.
So this is aggregated at month level with my time dimension. Okay?
Right.
This is at day level. So now I need to even have one dimension which is aggregated at that level. So I will have something called DIM month aggregate or DIM months, dimension months. So where your month is a primary key there, right? Because if I take DIM time, this will have keys at what level? Day level, right? Obviously months will keep getting repeated. It's not a primary key in your month is not a primary key in DIM timetable. Month is only a primary key if you create something called DIM months, and if you are using this for aggregation, all these aggregate tables can be used with this join like this. Generally you will have for time dimension only because you store weekly data or monthly data like that. So generally for months you create an aggregate table and you have the data stored at that level, even in aggregate table dimension tables also. Okay.
So if we have a aggregated fact, this means we would be having aggregated dimension as well.
Most of the cases, yes, you have it. Yes, you have it. You should have it. That is what an ideal scenario says. Okay. Alright. So because I cannot see the primary key foreign key concept goes off here if I am not doing that. You can go and you can refer your RPD and get me if there is any scenario where your fact table and is aggregated and where your dimension table is not aggregated. You can look into that. It's very easy. You can go through the list of facts, and what happens is your facts has something. One second. Your fact. Yeah, correct. What you do? You go to your fact. Click on the logical table source in your repository. Ask your team members if someone has, right. Just double click on the logical table source. You have something called as content. In the tab, you have something called as content for logical table source. Okay. There you will have all the dimension tables that are joined to a particular fact, and you have dimension hierarchies also. So just bring those values. Otherwise there is one more scenario also. What you can do,
Sir, can you explain this concept again, this aggregate dimension one?
This we will discuss. This we have a separate chapter for practice. We will bring import aggregate tables, and we have a separate practice for this. Don't worry. Okay. This I am just giving you a brief idea, just how aggregate tables are and how all these are stored. There is an aggregation content tab. Okay, so there what we have, we define aggregation content for each fact table. So there I know I'm just remembering. So in my RPD also. For type, what we did, we have different tables. Okay, we have. Okay, generally when I configured it with different dimension tables only, because I'm just remembering if I had implemented any with the existing dimension or anything like that. Okay, so we went with different dimensions only, because that fact table, if it is aggregated, you have to go with it, because the same fact table cannot be joined with. See, this table, when I say this, right, order aggregate fact, the same thing I cannot join with DAM time, right? I can still join with month level, but if I give at month level and all, I don't think so. It goes and properly hits up the table. Like multiple keys are present, so that's the reason we should avoid that. Okay, so we'll discuss about this. We have a chapter for this. So in our syllabus, okay, we have a chapter for this. You guys need not to worry about this. Okay, so just keep in mind we have aggregate tables and all this. Okay, so yeah, so it's 8:45. I can't start OBIEE 11G architecture. Okay, it's pretty difficult for us. No, this I am telling you, right? Identify fact table. Yeah. Next is identify your dimensions, and you have to define, identify attributes and select facts, and just all these steps. So you can have all these steps and make a join in general. So we'll see all these concepts. You need not to worry. So what is a star? What is a dimension? What is a fact? How to import them? How to make join between each and every table? And how to design a brand new RPD. All those stuff will be designed from our just one more session. I'll explain you about architecture once again, and then we can start with our practice immediately. Okay, so fine.
Pratap,
Uh,
Yeah.
couple
what is
of questions.
factless fact?
Yes, yeah, you can go ahead.
What is
Uh,
factless fact table?
Okay. Oh, I didn't mention about that. Yeah, so factless fact is a table where you don't have measures. You have only foreign keys. Factless fact will not have any measure. It will have only foreign keys.
so is it being practically used or just for theoretical purpose we have this?
Uh,
Any
uh,
example?
I didn't use it practically. Yeah, practically we use it. We use it, but I didn't use. We have some projects. I have seen some other project where they used factless fact, but see, very rare scenarios, you can say. Factless facts can be used. See, what is there? You can use them with multiple dimensions. If you want to get data from multiple dimensions, you can still go with a factless fact. We don't care whether it's a factless fact or whether it has a fact with measures or something. We can go for that.
Okay, Pratap, if we go with this BI apps, right?
Yeah.
You said like these use star schemas and not snowflake schemas.
No. See, I am not telling that most of the scenarios. I meant to say this is properly designed. BI apps also can have snowflakes, right? Why can't it have?
So that is what I am asking. Like, why can't it have?
It
I think
can
it is
have. No, I
loosely
am
based,
telling.
not a typical star schema. It is not a typical snowflake, I guess.
Yeah. See, it is not like a rule. You should have. See, snowflakes are also okay. Minimal. You see, you can't do everything like in one table itself. You can have some extensions, and you might be designing it. But I am telling ideal case scenarios. Most of the times these are like standards, right? So they have done everything. So if I see, we have a project where our whole every data warehouse table is manually created and set up. So are these guys, do you think are these guys intelligent enough to create a fact table and dimension table and make sure that these guys will have everything in like a proper standard convention? No, they
If
have
it is done manually, then I am sure like it would be snowflake only.
snowflake only. Yeah, so BI apps also will have some snowflakes, but see, till date, when what I have come across, most of the times we avoided that those type of things. So in previous projects also, it's now like we are working on 7964 version. So even there, I see hardly we are using mostly time dimension. One is like W fund fact, and one more is performance fund f. So most of the times I didn't see any this one. snowflake one there. It's like pure star only. So even in the previous project what I had, there also it's a BI apps implementation. There also we had only stars.
So even if we add one more dimension to it, where dimension is joined to a dimension,
Yeah.
it becomes snowflake from a starflake, right?
Yes, correct. It is, see, let them add it. We don't care. In OBIEE, what we can do, we can still make it as a star.
But you said like OBIEE only supports star. That is little confusing to me. How does it manage
Yeah.
that?
So in RPD, you have three layers in OBIEE. Okay, let me show you in diagram. So see, RPD is just like a normal sheet like this. When you open RPD, it will appear like this only to you. What it will have? It will have certain tabs. So when I say RPD, it's a repository where you develop all your metadata in OBIEE, right? You understand that, right?
Uh-huh.
So your RPD will look like this. And what is written here? You have something called as physical. It will be like this only. I think if you open your project's RPD, you can see this. Physical, you have something called as business model and mapping layer or BMM. Here you have something called as presentation. Exactly. Your BMM layer is the core layer. You call it as logical layer. So this is the core layer which is very important for your Oracle BI server to module a logical query. And using this logical query, it automatically generates a physical query also and sends the query to your database. So how it will send to your database? Obviously, there should be some link up with your database from your application, from UI. UI user can see report. So how he is doing that? The Oracle BI server can take help of your BMM layer, and it knows which physical table to be contacted for certain information. So all this we will design, just keep in mind. So what I am saying, if my data warehouse has a Snowflake schema, obviously what I will do, I will have tables like this: table 1, table 2, table 3 I have pulled. So here table 4. So I have dimension to dimension join here in my physical layer, because I cannot avoid anything in physical layer, right? Whatever is there in your data warehouse, this physical layer acts as the same thing. It is like it contains metadata of your data. Okay, so it contains the meaning, keys, all the joins and everything. We will see how to design, don't worry. Okay, just keep in mind. So now your physical layer has a snowflake schema, right? You are agreeing with it, right?
Yes.
Yes. No, I am saying OBIEE does not support your snowflakes. It can only support star. So where OBIEE consistency, or where your Oracle BI server really works on, is this business model and mapping layer. So your physical layer is just like a layer where you can give metadata, but here your real development or your real implementation begins. Everything in business layer. So here what you do, for suppose say I have suppose say this is dimension 1, dimension 2, dimension 3 and fact. So now tell me which two dimensions should be snowflake, so that we will design a business layer.
D1, D2 is snowflake.
D1, D2 is snowflake. Okay, D1 is referring D2. D1 has a foreign key, D2 has primary key. Is that fine?
Yeah.
Okay. Now what I do in my business model and mapping layer, I bring fact here. I bring D3 table here. I bring D1. I will not bring D2. You told D2 is snowflake. I will not bring D2 now. Fine?
Okay.
Okay.
Yeah.
Now you want me to get data from D2. How will you handle it? It is the question mark. Right?
Yeah.
Yeah. So here you have fact. Here you have D3. Here you have D1. So there is, in D1, I have something called as a logical table source. So D1 table, I'll double click it. When I double click it, I have four options. One is general tab, one is column mapping, one more is content, one more is aggregation. Okay. So in D1 general tab, I have something called as joins in the middle. Okay, in the middle. There, what I can do, in physical layer, if a particular D1 table is joined to any other dimension or any other fact, you can bring that as a inner source. It will not appear anywhere in your BMM layer. It will be inside this. Okay, inside D1. In general tab, you can have there will be a plus icon. You click on plus icon, you bring D2 table into D1. So your D2 table again will be brought into your D1, and all the columns from D2 can be used, and you have to define, is it an inner join, or is it a full outer join, or is it an outer join, or is it right outer join. All that can be defined. Even those criteria can be defined between your D1 and D2. Based on that criteria, you can have your D1 D2 join, and all that relevant information will flow into your tables like this.
So you mean in a way you are including the D2 columns in D1 itself with the help of a join?
Exactly.
So
You
we are
should
not
do.
bringing
Yes,
a
you should do
dimension,
that
right?
only. You should do that only. You should include your D2 columns also in D1 itself.
And if we try to bring D2 as well, will it throw an error over here?
Obviously, how will you join? Right? See, your tool will only understand 1:n relationship. One side dimension table will be there, n side fact table will be there. When I make D1 and D2 as a fact dimension, right? D1 is on the foreign key side, and again D1 is on the primary key side for one more fact. So it's like a conflict. It will not allow you
Okay.
like that. Okay,
Okay.
fine.
Uh, yeah, fine.
We will see this. We will implement this scenario. You don't worry. We have this scenario implementation also.
Yeah.
Okay,
So,
fine.
that we discussed like the snowflake and the starflake schema, right?
Yeah.
So, uh, I just want to bring in the concept of a cube. How does it work? I mean, if we are storing, if our data warehouse is based on a starflake or snowflake,
See,
I
that's
mean,
what
how
I'm
does
saying.
this come
Cubes,
into the picture?
cubes is completely different.
But I read it somewhere that it's the unit of dimensional modeling only and how data is stored in a data warehouse.
Mm, no idea on that part actually. You can say. I really didn't come across cubes or anything. So cubes are, I don't think so. We use cubes in BI apps also.
Okay, my point is like even if we are using at the database level, we are using cubes, then in OBI we are not implementing it, right? So is there a way to handle cubes as well, like you did it for Snowflake schema?
Yes, I told you right. OBIE doesn't support your cube concept and all. It's not like HOLAP tool. It's ROLAP only.
Yeah, that is what I am asking. Like OBI doesn't support Snowflake also, right? So there is a way
No, no,
how
no,
to
no, no,
call
no.
that.
Snowflake it supports, right? Physical layer you bring and you model it. See, ROLAP tool, when I say ROLAP, relational OLAP, you have tables and joins. Let the joins be present in any way. We will handle it. Okay?
Yeah, till
I
physical
don't
layer
care.
it will support, right?
I
Yeah.
don't care whether it is a star or snowflake. I want a relational OLAP. I want tables. I want joins. Give me that. Whether it is OLTP, OLAP, anything, I don't care. I'll make a report. Give me OLTP tables also. I'll make report. Why do I care whether it is a fact? All I need is a table, primary key, foreign key. That's it. Right? Your OBI does
Yeah, but
not know whether which is the data warehouse and which is the database. Does it know? No,
no.
it really does not know. All the thing it needs is a foreign key, primary key, and a table. That's it. Okay?
Yeah.
Okay, fine. Okay then. So we'll catch up tomorrow then. Fine.
Right.
Okay. Thanks. Thanks, guys.
Thank you.
Thank you.